thanks for sticking around all day for this, being part of this. It's a big step to come to NEO's first Dev conference. We're from Singapore, and it's pretty cool that I didn't know what to expect. I was like, okay, NEO primarily out of China, we're out of Singapore, coming to San Francisco for Devcon. Didn't know if, how the turnout would be, so I was super impressed the whole day. In the morning when everybody was there, 700 plus people, everybody sticking around, lots of questions being asked. So one thing we like to do is, this is the Bluzelle shirt that we have. We usually have kind of a trivia question thing that if you come up to us, you'll see my CTO around here. He's wearing the same shirt. So if you can guess all 4 names, there's a theme running to it. We've got t-shirts to give away. So we'll be doing that today and tomorrow. So Bluzelle, let me talk about us then. I'm supposed to press the play button? It's turning the left one. It's turning the screen on the left.
It's over on that screen? Is it on the side?
Yeah, it's changing the wrong screen. Yeah. Oh, there we go. Okay, so this slide is really about, so we've been doing this for a few years. Bluzelle, my CTO, and I found it in 2014, and what we really did was, let's just do some blockchain projects and cut our teeth. The reason I'm showing those brands is because it really ties into why we came up with this database product. So we moved to Singapore 2 years ago from Vancouver. Both of us had worked actually in Silicon Valley. My prior startup was funded by 500 startups as well. So we thought that, okay, enterprises is where everything's going, that needs to use blockchain. So we moved to Singapore early 2016. Actually, it was exactly 2 years ago today. So there, fortunately, we were able to work with a bunch of these projects, like, working with OCBC, which is one of the biggest Singaporean banks, HSBC, and MUFG, which is a Japanese bank. And what we discovered was we built a digital identity system for them so they can share consumer data, really speed up the onboarding process of KYC, know your customer, from the customer experience and the back-end bank experience. So basically do a private blockchain, validate the person who they are. If they go from one bank to another, they don't have to supply any of that information because they've been onboarded right away because the network already validated them. So we built that on Ethereum, built that product. The problem we came across was that, wait, we can validate the person, we can store all the files, in a decentralized manner. But Neeraj, my CTO, said, hey, we're having a problem of the actual data behind these consumers. Where are we storing that? That's still going to be done in a centralized manner. It's not efficient because we've got, a decentralized application, we've got built on Ethereum, but where the data is actually being stored is centralized, and that's a problem. It's not efficient how we were connecting it to our product. We basically had to take Microsoft Azure and just kind of blockchainify it. Wasn't ideal. So we said, this is going to be a problem for us. And going forward, we're like, if we're having this problem, and we believe that the future is blockchain and decentralized applications, everyone's going to have this problem. So why don't we just start focusing in on that and use that as our main thing? The main thing was it actually came out from enterprises trying to solve them, but really what we decided was that's not the group we want to target. Because enterprises, who's building enterprises apps here? Anybody? Yeah, I would recommend changing that course. Only reason is because they take a really long time to decide, and our technology and your guys' products are moving so fast that they just can't keep up. So we said, you know what, we can't focus on them. The real problem is if we aim at small to mid-sized developers who are willing to take chances, really learn what it is, they'll be faster adopters, and we can test this technology. And really, the big enterprises are going to spend big money on the oracles and centralized systems. Let's have an enterprise-grade product that's really focused at developers. So that's when we decided let's build a decentralized database, but aim it at small to mid-sized developers, starting with blockchain dApps. So why is this a problem? On a bigger scale, everybody realizes that the current internet is not ready for all this data that's being consumed. In just 2 years, they're predicting that if there's 4 billion people connected around the world, we're going to have over 25 billion devices. That's basically 6 devices for every single connected person in the world. All the data that's being consumed between all these applications is growing at an extremely exponential rate. The current internet that we have, the centralized one, just doesn't have the infrastructure ready to handle all that, and that's why you're having all these problems. So really was like, this isn't just a blockchain problem, this is a global problem of how is all this data can be managed and stored in a proper way. I mean, here are just some headlines that have come up, and this is just basically over the past year. Everybody probably heard, because we're all from, originally from Canada and the US, the Equifax breach, 200 million plus records of people's data records getting stolen. That should not be happening. It's getting so bad that even Congress and everybody is thinking about that. If executives are covering up data leaks and data breaches, they should be facing jail time. And what they're saying is, with the current systems that we have, this problem is just going to get bigger and bigger before it gets solved. So it's up to basically companies in this space to start solving some of these things. So why a decentralized system? The main thing here, what we're showing is the past, present, and future. In the past, you had basically single system models. Everybody probably understands this, that, hey, it's all on premise, everything's done at one place. Problem is that any of those systems, whether it's the application, the database runtime, the file system, if those get breached or go down, the entire system goes down. So that doesn't work. So we evolved to a cloud model, but still centralized. So though you have, different zones and clusters, it seems like it's kind of better, but if the load balancer there goes down in the middle, the system goes down. If a hacker goes into zone 1, with a little bit of more effort, without too much extra effort, they can probably go to zone 2 and take the rest of the data. So that doesn't happen. In the future, what we're building is a true decentralized model using the blockchain principles, where we're going to have all these nodes out there, and basically Airbnb style, similar to Filecoin and storage, we're basically taking unused storage space, allowing people to download the Bluzelle protocol, and in doing so, separating all the data into a decentralized network, and that's everything will be exchanged. The users will pay with a Bluzelle token, and the producers on the network, instead of mining for Bitcoin or anything else, they can basically earn a Bluzelle token. The real things that we see here is that it solves the security issue, the reliability. Neeraj, my CTO, his biggest thing as a looking at databases is that what I really care even more about price is reliability, that this thing's not going to go down. I'm going to be able to get my data when I want. And then the other thing is that as users come up, and even if we don't have the revenue coming in, we need this thing to scale at a proper pace that other small to mid-sized developers can. Enterprises are going to pay for scalability. They don't care. But what about the rest of us? So that's why it's important to have that product, that it scales at a right rate that everybody can afford. The 3 core pieces of our technology are, everybody's basically obviously heard of swarming, and why it's important to a database. So the question we always get asked is, what about latency? Like if you use a decentralized model and it's not on premise, there's going to be speed issues, so what are you going to do about that? And as developers, all of us, we need our data fast. If it takes a long time to get it, what's the use of the system? So by using swarming, what we're doing is, instead of having a universal state consensus, what we're basically saying is, Bluzelle is, let's say, the universe. All the swarms of the nodes are basically galaxies. So all we need to do is basically have the galaxies come in consensus, so the swarms, and then that allowed us to have the speed and have no latency issues. What we're also doing is taking the data, partitioning it, sharding it, as everybody knows, and replicating it across all the nodes. So a swarm might just so let's just say something said Pavel Bains lives at XYZ Holland Road. That data would be broken up as into pieces, spread out amongst an entire swarm, and then the rest of the data, maybe like Pavel is in one swarm, Bains is another, Holland Road where I live is another. That's all cut up, spread across several swarms. So when it's retrieved, all we need is consensus at the swarm level, and it puts the entire pieces of the puzzle back together. And then consensus, what we're also using is not just on the data being correct where it is, but also for the actors, the producers on the nodes in the system. We want to make sure that everybody's, there's KPIs built in so that, hey, they have a fast internet connection, They're playing by the rules. They're putting up a stake in the system as well. So that way, people who aren't performing well, nodes that aren't, we can boot them off. The network can recognize it and then keep the system running properly. So if we can, oh good, the video's up. So what we're doing here is showing, this is a simulation of the swarm in effect. So what you see is the green circles are all the nodes that are live on the system. The red ones you'll see are, well, the table's there just showing the data that's coming across. The red ones are nodes coming off the system, basically being kicked out. And then blue ones are new nodes coming back onto a swarm, so being born. So you've got green is current, blue is coming out, red dying off. And what you see is that all the data stays persistent on the left, everything's being written, sent to the database, and it's persistent, nothing is really breaking. So whether we scale up and add a bunch of new nodes on, or scale back down, the system stays persistent. So that was really key, is that people always ask, what if one node dies off and my data's gone? It doesn't matter, it's replicated, it's on somewhere else, and we can still retrieve it. What if, one system, guy just turns his computer off? Doesn't matter, the rest of the swarm already has it. What if a new one comes on? How quickly can I get on? It comes right away. A nice little use case that we try to talk to is just long-term vision, is that not just blockchain apps, this thing should be, a decentralized database should be used by everybody out there. One easy one we like to understand is just like applying it to video games and PlayStations. My kids have a PlayStation and an Xbox. These systems have way more power that they'll ever need to use. Like there's over 1 terabyte of storage on there. The problems you see in video games, because I come from that space, is that one, the game costs like $60 US minimum. You've got all this extra hardware sitting around, and then EA Sports, let's say from Madden, they're running leagues all the time. They got to do player updates. All the data and roster of it has to be stored somewhere. And usually they're probably doing it on a central place, AWS or wherever else, paying enormous costs. So if we apply the Bluezelle decentralized database to it and say, hey, let's network all these unused PlayStations out there. Now the person who owns that PlayStation, who bought that game, they can basically start earning tokens and say, okay, that subsidizes my cost. EA Sports, which was having this enormous operating cost of running it, they can say, you know what? Let all the PlayStations and Xboxes out there run these nodes and store this data that we're having for the games themselves. So that way we solve a problem across it. So that's what we say, is that we're starting with Bluezelle, starting with blockchain projects, Dapps, but really want to move more into the mainstream over the next couple of years because everybody can benefit from the system. Here's one of our partners that we're going to be working with, 0x. I'm pretty sure it's a local company. People are familiar with the protocol. So their main thing is 0x isn't really our customer. We're almost a partner of ours, because for them what's important is the relayers or the market makers to keep all their order books in a tidy, proper way. Right now, any relayer on there has to basically keep all the orders that are going and manage them. And there's no real consistency. There's no best practices. If we can work with, by working with 0x, we can give them 0x and say, hey, we've got a value-add product, relayers join here, and we can keep everything nice and simple and clean and tidy, that you can get your data how you want. So if we walk through this model, and this could be for anything on the NEO Dapps that we'll be integrating into, is that the relayer, they connect to our system through our API abstraction layer. They've got their private keys and public keys. They make a request. The Bluzelle network basically takes that and finds a random node on the swarm, saying, okay, where is this data sitting, and it belongs to this relayer. That correct swarm is accessed by the Bluzelle hash table and the lookup protocol, and it basically reads that encrypted value and basically sends it back to the relayer. They've got the private keys, they decrypt it, and they've got it there. So it becomes really fluid, and that's how basically they'll be able to create data, read, update, and delete all in real time. A little bit about our team. Myself, like I said, I came from a video game background, running companies for Disney, doing projects with Microsoft. My CTO, Neeraj, he used to work for Google, Lufthansa. He was also part of ZeroBlock, which a few years ago was one of the earlier blockchain exits bought by Blockchain, Blockchain.info, the wallet company. The rest of our team has grown to 12 people over the past 6 months, primarily in machine learning, cognitive science, data networking. The bigger one is people always ask is, okay, this is a massive problem. How are you guys going to basically solve a lot of these things? We've been able to get some really good tech advisors on, mainly the three, Brian Fox, who wrote the GNU Bash script. He's an open source advocate, so he's come on. He's also the CTO of Orchid, the Orchid protocol. Prashant Malik, who was a creator of Cassandra, which was one of the first distributed databases. So these guys see us as the next evolution of going from a distributed system to a decentralized. And because these guys have gone through a lot of these problem areas before, they can help out. And then Alex Leverington, who's one of the first core developers at Ethereum, he's come on as advisor because they see the roadmap of what they're figuring out over the long run and can just help out overcome some of these challenges. Okay, so how you guys can get involved is you can hit up our GitHub right now. Neeraj is here to answer any questions as well. You can basically create your own mini swarm. Some guys have actually gone out there and used a Raspberry Pi and started running some nodes and swarms across that. The next big release will probably come out in April, where we have more to do. And really we're targeting like July will be the real functional ones. You can also join our community Slack. That really is not for ICO people, it's not for token buyers. Any ICO token questions are usually, we ask them to go somewhere else. Yeah, we're like, hey, there's somewhere else where you guys can go, and we'll delete those messages. This is strictly for the tech teams and the tech guys to directly talk to Neeraj and the rest of our team and ask those questions. So we've just set up a NEO channel on there as well. And yeah, feel free to come in and do that. If we have any other questions right now, we've got about a minute left, and we can answer anything. Yes, sir.
For the decentralized database, we have used one concept called big chain DB. Can you make some comparison between your approach and big chain DB?
Yeah. So the question is, Big Chain DB is another database company that's been around for a long time. And what's the differences? How we compare and contrast? So from what we know of theirs is that we basically take a different approach. Theirs is more about, a lot of their target market has been in enterprises. So enterprises like to keep everything on premise. So they're building, basically taking existing databases and kind of blockchainifying it and saying, hey, here's an on-premise decentralized solution. So if you're a bank and have multiple divisions, here we go, you can put this on premise, and here you go. Like that's how theirs works. It's still decentralized, but it's mainly for that customer. What we're doing is, no, we're starting from ground up and building a brand new protocol. So you guys so everybody else just plug into us. You don't need to manage hardware. You don't need to have it on premise. You just go onto the Bluzelle protocol to do so. So different ways to skin a cat. Theirs works more for enterprises. We're really aiming at the small developers and mid-sized developers.
What do you achieve consensus? What's the consensus algorithm? Consensus?
How we go? The question is.
Sorry, how do you achieve the consensus algorithm? Like, what is the algorithm? POS or PBFT? What is the algorithm you use?
Neeraj likes to answer this one because don't you waste does it? You can just talk.
Yeah. So your question is, what kind of consensus do we use? We're using a modified version of Raft. So we do consensus on two different levels. We're doing consensus on two different levels. We have consensus at the swarm level, and we're using a modified form of Raft consensus, which allows you to elect a leader. And of course, if the leader goes down, which is statistically possible, a new leader gets elected really quickly. And then we also have consensus going on between the swarms themselves, because swarms can go down. A swarm can't go down, but we can basically grow the network as more and more nodes get added. We grow the swarm, and of course, the entire storage capacity of the network grows.
Yes. The problem with the Raft is it cannot really follow like one node.
Yeah, exactly. That's why we're modifying it. It doesn't work out of the box. It has to be heavily modified. It's the closest thing to what's published out there.
Okay, I think we're out of time. Thanks, guys.